When we find inverses, we are looking to, when we verify inverses, we're looking to determine whether or not we're certain that this works as an inverse. And to do that, we can use a composite function, or we can just use a number. And it takes several steps, so it's important to know that part. The first thing I'm going to do is the number method. So I'm going to pick a value to put in for x, and I'm just going to use x equals 4. So I'm going to find f of 4. So that means I plug 4 in for x, and then I evaluate. So that's going to give me 12, drop down to minus 10, which equals 2. And then what I'm going to do is I'm going to take that 2, and I'm going to put it in for x in my inverse function. And so I have f negative 1 of x equal, oops, not of x. Whoops, hang on. F of 2, and then I'm going to put 2 in for x plus 10 divided by 3. So then I'm going to evaluate that. 10 plus 2 is 12, and 12 divided by 3 is 4. So the number I start out with after I run it through both equations should be the number I end up with. And that's how I verify that these two equations are inverses. So that's one method. The other method is what's called a composite function, meaning I take the entire inverse function or the entire original function. I don't think it really matters which. And I put one inside the other. So if I take f of f negative 1 of x, so I'm taking the whole x plus 10 over 3, and I'm going to put it in for x in my equation here. So the important thing here is to be careful with the order of operations. So I'm going to take 3 from my original equation, and then instead of x, I'm going to put the entire inverse function, x plus 10 over 3, and then minus 10 from the equation again. And then one step at a time, I'm going to eliminate what I can. What you don't want to do here is start just crossing stuff out, because you're always going to end up with x if it's done correctly. So you need to do it step by step. So I can't do anything with this 10 until I get rid of my fraction. So 3 times something and then divided by something is going to give me 1, so I can, or it's going to give me that something. So the 3's divide out at this step. And then what I'm left with is x plus 10 and then minus 10. 10 minus 10 is 0, so what I'm left with is x. And that verifies that I've done it correctly. If I wanted to do it the other way around and put f inverse of f of x, I can take my original function, 3x plus 10, and put it in for x in the inverse function, and the same thing should happen. So instead of x, I'm going to put 3x minus 10, and then I'm going to put the rest of this function, plus 10 over 3. So then I'm going to simplify it from there. This is a grouping symbol when I have a whole bunch of stuff on one part of a fraction. I'm going to simplify this part first. So negative 10 plus 10, that's going to give me 0, so that goes away. What I'm left with is 3x divided by 3. And at that step, 3 divided by 3 is going to give me 1, and so I'm left with 1x, or just x. So when you use a composite function, you should always end up with x. But know this for tests, anything like that, you have to show what happened at what step, because we always know it comes out as x. So if you just cross everything out except for x, I can't tell that you were doing that in the correct order. So this method is fine, this method is fine, one or the other. To be able to do highly proficient for this, you need to be able to use both the number method and the composite function method. So just to finish this one off, yes, these are inverses. All right, hope that helps.